Good afternoon. So in our previous lecture, we looked at prospective reserves, where we said that in the prospective case, we look at the future cash flows. Now we want to look at the reverse case, which is the retrospective reserves. So in this case, we'll be looking at historical cash flows. Yeah, so with that regard, we'll be looking at computation of respective reserves for these whole life insurance contracts based on the accumulated value of premiums that have been received to the date at which you are evaluating your reserves, less the accumulated benefits and expenses that have already been paid. So retrospective in that case is based on actual cash flows that have actually happened. But you can see we already know that accumulation is the reverse of the determination of the present value. And so that simply means that we'll be still evaluating our cash flows in the same way that we do it, only that in this case, instead of discounting to determine the present value, we'll now be accumulating. So we look at the different types of contracts, and later on we shall see situations where under which the prospective reserves equal to the retrospectives. So we'll begin with the examples. So here we have a question. A fund of 1 million has 10,000 members, aged 40. The fund accumulates at an interest rate of 4% per annum effective and will be divided among members who survive to age 60. Based on the AM92 ultimate mortality, calculate the expected payout for each survivor. So it means that yes, we want to first of all determine what will be the accumulation of this initial fund of 1 million over the next, these are how many years? 60 minus 40 over the next 20 years, so that we determine by the time this fund is maturing, which is in 20 years time, because we are told that the fund accumulates at the rate of 4% and will be divided between members who survive to age 60. So no payment is actually being made between ages 40 and 60. So it means that the fund is first of all accumulating over the next 20 years, and therefore from your fundamentals of actuarial maths 1, we know how we accumulate cash flows. So the accumulation factor in this case becomes 1 plus I raised to n, where my I is 4% and my n is the difference between 60 and 40, which is 20. So we are saying that by the end of the 20 years, the accumulated value of the fund will be equal to the 2.1 million as computed. So we have the value of the fund. And then it goes ahead. So this fund is only payable to the people who survive to age 60. And therefore, if you want to calculate the expected payout for each survivor, we do not expect that all members, all the 10,000 members who are initial contributors to the fund will actually survive to age 60. So it means, therefore, we must compute how many people do we expect to survive to age 60. So it means, therefore, we need to compute what's the probability that an individual person, age 40, will survive to age 60. That brings us to computation of P40, 20. So this is the probability that a life aged 40 will survive to age 60. And therefore, if you have 10,000 members, then if you multiply that with that probability of survival, it simply means that 9,422 members will actually survive. So in now determining, remember our question is, what is the expected payout for each survivor? And we're using the AM92 tables. So we're using the AM92 tables. And so in computing this probability of survival, so instead of us now using our original number of members as 10,000, we will use the new number of 9,422, simply because we do not expect everyone to survive. And therefore, it simply means that our expected payouts will be the accumulation of the fund divided by the number of actual people who survived to the age of 60. So let's look at another example so that we see how this is helpful. So here we have a case of a pure endowment. So write down the prospective accumulation after 10 years of a benefit payable under pure endowment contract, which has a benefit amount of 50,000 and a term of 10 years. So in this case, the accumulated value of the fund will simply again be equal to the initial amount of 50,000. Why is that the case? Because the benefit, this benefit, first of all, this payment of 50,000 is made at the accumulation date. So in that case, there's no interest that needs to be added. So we're evaluating it at 10 years, and it was actually a 10-year pure endowment value, or its value that has accumulated over the 10 years will be equal to the maturity benefit of 50,000. And then again, if this benefit, remember it's a pure endowment, which is only payable on survivorship. So it means that this person must have survived over the next 10 years. And since we are evaluating it again after 10 years, it means that the probability of this person having actually survived for them to receive this benefit is actually 1. So you'd have your 50,000 divided by 1. So we can look at a different case so that we see the distinction. So here we have a term assurance contract. So write down an expression of the retrospective accumulation at the end of T years, where T is less than N, of the payments made under the term assurance contract by that time. So here we know that under a term assurance contract, the benefit is paid upon death before the end of the term. So again, like we had it, it means that we need to determine what's the accumulation up until time T. So it's up until time T. But we need to divide that with the probability of this person surviving up to that time T. Remember, we are looking at historical cash flows. Yeah. And in historical cash flows, it means that if this contract still exists, then it means that this person is still alive. So it's true, and we know that a term assurance is payable only upon death. But in the case of which we are examining these retrospective reserves, we are looking at what has been the accumulation of premiums less the accumulation of benefits and expenses. So in this regard, we want to compute the retrospective accumulation of these benefits attached to the term assurance. So you know, if I have amount of if you consider this symbol here, the assurance, the expected present value of this term assurance, this simply denotes the mean present value of that term assurance contract for this life as at age X. However, if you were considering this to be an N-year term assurance, then you'd expect instead of the T here, we have as N. But now we want to compute the accumulation of this benefit as at time T, which is less than N, which is less than the expiry period of our contracts. So I'm only considering the cash flows that will have been paid from age X to age X plus T. And therefore, any other cash flows beyond the age of X plus T all the way to age X plus N, I am not interested in those cash flows with when I'm looking at the retrospective reserves. So if we are considering the cash flows of this term assurance benefit with the sum assured benefit of 1, only considering that benefit or that cash flow for the time period between ages X and X plus T, it means that the mean present value or the expected present value of that term assurance contract is AXT with a stress on X and not AXN with a stress on X. So in that case, we are saying that the mean present value of the cash flows as that between ages X and X plus T will only be equal to our term, which is what we have here. And we are saying, we are considering that because our interest is in accumulating the cash flows between ages X and X plus T, because we want to evaluate the retrospective accumulation as at the end of T years. So you know that if I have an amount of P sitting at time 0, and I wanted to determine its value at time T, then it simply means I need to accumulate my P over a given rate of interest I over the next T years, so that at time T, I will have the accumulated value as P times 1 plus I raised to T. So it simply means that we can read my value as at time T to be simply the accumulated value of my original present value of P. So it simply means that whatever I have, my assurance EPV here denotes the present value of my cash flow. So this, again, it is simply what we have here. So the assurance MPV here is my present value. So the difference between what I'm having in this equation is the time N. So this is the accumulation of this retrospective accumulation as at the end of N years, but our interest is in T, so we have it as T. So it's the mean present value. So if I want to determine the accumulation, I need to multiply that with the accumulation factor. So my accumulation factor in the case of T years would have that as 1 plus I raised to T. And because this is, again, because we are looking at historical cash flows, which have already occurred, so it means that this life aged X must have survived from age X to X plus T. They must have survived from the inception of the policy over the T years. So therefore, we must incorporate this probability below here of surviving from age X to X plus T. So how do we move from what we have here to our second equation, which is what is actually represented here in our solution? If you remember well, we defined this as a commutation factor, dx, where we say that dx is equivalent to v raised to x, where v is the discounting factor, times lx. So our dx here is equal to v raised to x times lx. So if you have dx plus n, it simply means that you're looking at v raised to x plus n times lx plus n. And therefore, I can express this, so this accumulation factor in terms of v, and I can express my probability of life here in terms of the lx. So that in so doing, I will have, so we know accumulation is the reverse of discounting. And therefore, if I want to express express my 1 plus I raised to n in terms of Vx and Vx plus n, then to the numerator, I should have V raised to x divided by, to my denominator, V raised to x plus n. So that if you expand or you express that in terms of I, then what will actually, it will simplify to your accumulation factor 1 plus I raised to n. In a similar way, we can now express our probability of survival from hx to x plus n in terms of Lx, and this should be, so remember it is in the denominator, so in that case, what will appear to your numerator will be Lx divided by Lx plus n. So it simply means that your original equation in terms of commutation function simply becomes our second equation here, so that our numerator will be V raised to x times Lx, and in our denominator we'll have that as V raised to x plus n times Lx plus n. So in this case, because we're looking at now the retrospective accumulation at the end of t years, where your time t is less than n, considering an n-year term assurance contract, then it simply means that the retrospective accumulation is equal to this as our amount. So let's look at a question and see how this comes about. So all this is pegged to our original example, where we are saying that in considering these historical cash flows, we expect that these cash flows continued to be paid because the policy was in force. And for the policy to have been enforced, it means that this life was still alive. And in so doing, once you accumulate your cash flow, you must incorporate the probability of survival by dividing your accumulation with that probability of survival. So you can look at the example. So in our example, we have that John, age 35, buys a term assurance policy that pays a benefit of 100,000 at the end of the year of his death if he dies before age 65. Calculate the retrospective accumulation of the benefit to time 10. So on the basis, so all these questions, when you're doing the pricing, when you're doing the expected value, the variances, the reserves, you'll always have a basis. So this is simply the assumption which you should use. So in this case, we're using AM92 ultimate for our mortality assumption and 6% per annum interest as our interest assumption. So we want to look at what is the retrospective accumulation. And we are accumulating this over the next 10 years. So in that first case, we already know, let's go back. So we already know, so this is a term assurance and the benefit are payable at the end of the year of death. We are not given, are we given the term? Oh yeah, we can determine the term because we already told that the benefit of 100,000 is payable at the end of the year of his death if he dies before age 65. So it means that we are dealing with a 30-year term assurance. So in that case, we are considering the retrospective accumulation at the end of 10 years, where my 10 is less than the 30 years. So in that case, we are evaluating. So this is a scenario where we were considering our sum assurance benefit to be a unit amount or an amount equal to 1. In this case, it is equals to 100,000. And therefore, the accumulation will be equal to the 100,000 times A. My X here becomes 35, and I put a stress on it, so that must occur first. And then my T here becomes 10 and not 30. because we are evaluating this retrospective accumulation of benefits for a period of 10 years. And then this becomes ds, my x is 35, my x plus t will be 45. And in this case, because we are dealing with the ultimate most stable, that surface, we shall look at a select case to see or to distinguish between the again, we know we can express. So here, there we have expressed in terms of commutation functions, which we said, or we were able to see that these two functions are actually equivalent. So you can choose to, or you can choose to use this particular expression. So if you go to your tables, for instance, we are looking at let's go to our AM92. I want to show you where you can locate that commutation function. So this is our AM92 table. So you have the different functions. So these are, so here we have, so this is our commutation function, which we are referring to. So you can choose to use this as your accumulation for the commutation function. That in that case, you'll be using this equation, or you can revert to the original equation. So it depends on the information, or it depends on the table and what is tabulated in the table. So if your table already has, you can compute this probability of survival directly, then you can go ahead and do so. So if we use that first formula, then we're looking, this is what we want to actually solve. So we already have our interest. So our interest here, we were given in the question. So we were computing this at 6% per annum interest. So it means that we need to evaluate this mean present value of the assurance benefit in the same approach that we did it for when we were evaluating these assurances. So we utilize the formula as it were, and we have our interest here, that should be 6%, and we know we can obtain this probability from the life table. So in this particular solution, it's possible to actually combine several terms. However, you can simply solve the question as it is. So once you get your expression, the first expression, which is already here, which is correct, you can independently compute. So you compute your MPV for the term using this as your expression. And then you compute your accumulation factor at 6%, and you compute your probability of survival from age 35 to 45. And once you're done, you simply evaluate the equation by multiplying and dividing respectively, so that you obtain your answer as the 1,210. So we can also look at another example. So this is a case where, again, we are now looking at a temporary annuity due. And you can see that the resultant retrospective accumulation is similar to that of the assurance, only that in this case you have the corresponding mean present value of the temporary annuity due. So once you have the EPV for this temporary annuity due, as we had determined previously, be it in the premium case, be it in the evaluation of annuities case, the way we compute our A due X angle N is the same. So in this case, because we want the retrospective accumulation, we accumulate it for the corresponding period and divide that by the probability of survival. And we have said that we are dividing this with the probability of survival because this accumulation would not have happened if this person was not alive. So these cash flows continue to exist because the policies continue to exist, and simply because that person is alive. So if you were evaluating the retrospective accumulation of this temporary annuity due as at time t, then everywhere we have n in this particular equation, would have that as t, would have that as t, and would have that as t. And we know for annuities, we can express the accumulation factor in terms of the symbol S, so that if you have it as an annuity due, then this becomes S due X angle N. So you can have that representation as well. So we can now look at an example. I think this is what we've already spoken of. So consider an annuity of 1 per annum that has expected present value at the start of a contract of, so this is the MPV at the start of the contract. Write down the expression, the retrospective accumulation to the integer time t for payments made after, for payments made by that date. So we simply multiply that with the accumulation factor and divide by the probability of surviving from age x, that is at the inception, to age x plus t. So in defining now, so we have looked at how do we compute the retrospective accumulation of benefits. We have seen how that has been, both for the assurance and for the annuity. So you now want to define our gross premium retrospective reserves. And we have said in this case, we are looking at accumulation. So how we define our gross premium retrospective reserve is that we take it to be the difference between the retrospective accumulation of past premiums minus the retrospective accumulation of past benefits and expenses. Yeah. So this equation here gives us the gross premium retrospective reserves. So you can see in both cases, we are looking at retrospective accumulation, the only difference being we are lessing from the premiums, the benefits and the expenses. So the accumulation factor here divided by the probability of survival, you realize whatever we have here as Lx divided by x plus t, that is the same as 1 over probability of surviving from age x to x plus t, that is pxt. So that is the accumulation factor divided by the probability of survival, and inside the bracket, what do we have? We have the mean present value or the expected present value of the premiums less the expected present value of the benefits and all other expenses. So from the how we were computing the premium, this is the equation we were using, yeah, where we were equating the MPV of premiums to the MPV of benefits and expenses. So you can see we are carrying on the same with the same knowledge. So and so this is our initial expense, our recurring expenses, and the final expenses. So this is now the equation tied to the gross premium retrospective reserve policy at duration t. And we are saying that the distinction here is we multiply with the accumulation factor and divide that with the probability of survival. So whatever you have here is the gross future loss random variable from now x to x plus t. So this here takes care of the accumulation. So if this contracts, so this is a whole life, we shall look at another case so that I bring out that distinction. So let's look at an example so that it's clear. So we have calculate the gross premium retrospective reserve at the end of the second policy year for a 5-year single premium endowment assurance with the sum assured of 30,000 payable on maturity or at the end of the year of earlier death issued to a 48-year-old. So in this case, we're assuming AM92 select mortality at the interest rate of 4% per annum effective. And the initial expenses are 360. So that is a one-off expense. Renewal expenses of 45 at the start of each year, excluding the first year. So that's a recurring expense. So this question may have been structured in a different way so that after the 48-year-old, you would have been told using the following bases. And then this will have been listed. Mortality, the AM92 select, interest 4%. Expenses, you have the initial as 360, renewal as 45 at the start of each year, excluding the first. So those are the different ways that can be arranged. So we want to calculate the gross prospective premium reserve, where we have seen it's simply the difference between the retrospective accumulation of premiums less the retrospective accumulation of benefits and expenses. So it means that first of all, we must determine what is the premium that was originally charged to this particular contract. Yeah. So first of all, that's the beginning, that's the genesis. So it's a 5-year single premium endowment assurance. So we must determine what is the value of this single premium. So we need to know the premium at the original point of the contract, as well as any the expenses and the benefits. So the first thing we do is to calculate the premium. So we are told that this is a 5-year single premium. So in that case, the P here will not have it as, let's say, P ADU 48 select angle 5. No, because it is a one-off payment which will be made at the start of the contract. So its present value will simply be P because it's only being paid once, and it is being paid once at the beginning of the contract. So we'll have that as simply P. So in determining our premium, we equate the expected present value of the premiums to the expected present value of the benefits plus EPV of the expenses. So that is simply what we're evaluating here. And we have said that the EPV for the premiums will be equal to P because it's a single premium endowment assurance. And that's the present value of that amount as at the inception. So we equate that to the MPV or the EPV of the benefits. So we are told sum assured of 30,000 payable on maturity or at the end of the year of death, and it is issued to a 48-year-old. So in that case, this is my sum assured S, the discounting factor or the discounting factor here being A X angle N. And in this case, because we're using select mortality, it means that my 48-year-old insured here is a select life. So that 48 needs to be select. And then my N here becomes the term of the contract, which is, in this case, the 5-year endowment assurance. So that's 5. So we now start attaching the mean present value of expenses. So we have the initial expense. We have it as 360. So that 360 was incurred at the start of the contract, and therefore its mean present value at that point is simply 360. So we do not discount it with any ADU whatsoever. We continue. So renewal expenses of 45, which start at the start of each year. So that means we are now looking at an annuity due case because it's a renewal expense which is being paid at the start of each year, excluding the first. So in that case, we'll have it as A due, again, 48 select for the next 5 years, but we less the first payment. So we now need to solve for this equation so that we get the premium. We've not even started anything on the retrospective reserve. We are first of all determining the premium. So we can now compute. So our assurance benefit here, you can compute it as such. This formula is the same as the one we used in the non-select case in the evaluation of assurances. However, in this select case, I want you to see this distinction, that once we get to, remember, our AM92 table has a select period of 2 years. So once you get to 2 years, the life ceases to be select. So that in this case, you can see our A58 is no longer select, because once you have 48 plus 2, sorry, 48 plus 5, which becomes 53, that additional 5 has already surpassed 2. So once you get to 2 and above, the life ceases to be select with respect to this AM92 tables. And therefore you'll use A53 and not A53 select. So I hope that distinction is very clear. So again, if we look at, so we want, first of all, to evaluate this probability. So in evaluating this probability again, we know that if you want to compute Pxn, then you usually have it as Lx plus n divided by Lx. And you realize our Lx will continue to be select in this case. But our Lx plus n will not be L53 select, but rather it will simply be L53. However, assuming we wanted, we were looking for P48, the probability that a 48-year-old select survives to age 49, then in that case, we would have had our numerator here being L48 select plus 1. Simply because, again, our select duration for the AM92 tables is 2. Again, another distinction, if we had, instead of this 5, we had it as 2, then in that case, I would have had my numerator here being L50 without the select. So ensure you revisit your ACS 212 on the aspect of reading the select life table. So otherwise, the formulas of how we evaluate these assurances will remain the same. The distinction comes in how you read the tables. So we solve for this using the appropriate tables and obtain that our premium is equal to the 25,201. So this is our premium. So we can now embark on determining the retrospective reserve. So it means that if we go back to our original formula, so this formula was for the whole life. So if we wanted to translate, we can as well look at it from the angle of now the endowment, because all we are trying to do is to look at what is the retrospective accumulation of past premiums less the retrospective accumulation of past benefits and expenses. So it means, so we now have premiums, we know how much this person has been paying for that period, or annually, in this case it was a single premium, so we know how much they have been paying, and we know what have been the expenses. So we now accumulate each of them. So we go back to our solution. So here's the premium we have computed, and it is one single premium. So the accumulation, the retrospective accumulation of this past premium, so it is one single amount. That's why we have it as without any discounting factor whatsoever. And we now, remember, we are looking at this reserve as at the end of the second policy year. So we multiply that with the accumulation factor and divide by the probability of survival over the next 2 years. And you can see, once I get to age 50, which is 48 plus 2, my life ceases to be select. So you're supposed to read L50 and not L50 select. So we are lessing from the retrospective accumulation of these premiums, the accumulation of benefits and expenses. So this term here has been factored out because it's common. It will be common throughout. So in this, whatever is in the square brackets only gives us the MPV of our cash flow. So the MPV of our benefits, remember this is for only the 2 years which we are considering the accumulation for. And therefore you have your 30,000, 48, select angle 2. So this is 2 and not 5 anymore. Then again, remember we are looking at historical cash flows, and we had our initial expense as part of our historical cash flow, so we must include that. And it's only one payment, so we have no discounting factor for it. And then again, for the recurring expenses, from the inception of the policy to the second year, we have only paid this amount once. So we have it as 45 a 48 angle 1, because we have only paid one renewal expense. So once you solve for this, then you have your retrospective reserve at the end of the second policy year. So the emphasis here is that ensure that you read the correct tables. And you can see in this case, once you get to your select period, the life ceases to be select. So you compute the corresponding notations. So here you have the MPV for the assurance over the next 2 years, evaluated as such. And you have this one for the annuity being evaluated here. At the corresponding rate, where the rate was, so in this case, the rate was 4%. So evaluating all those cash flows as at 4%, so that you obtain your retrospective reserve as 26,808. So ensure you verify those values. So once you have the reserve, let's say for the previous year, it's possible for you to compute the reserve for the next year without having to go through the entire computation, as long as you're assuming the same basis. Yeah. So it means that if, for instance, the retrospective reserve at the end of the first year will again be equal to the premium less initial expenses plus interest and less the expected cost of cover, divided again by the probability of surviving. So you would have it equal to, so this would have been the retrospective by the end of the first year. However, in our case, we have computed the prospective reserve, retrospective reserve as at the end of the second year. So if you did the same for the reserve as at the first year, then this should have been the value, 25,828, which you can verify using the same approach. But now considering that you want to evaluate this accumulation as at the end of the first year. So if we now want to compute the retrospective reserve as at the end of the second year from the retrospective reserve obtained as at the end of the first year, then you simply take it to be the reserve held as at the end of the first year. From it, you subtract any expenses. So in this case, we only had a renewal expense, and you accumulate that for the 1 year. So you're now accumulating that difference, the difference of the reserve in the previous year minus any expenses, which in this case was only a renewal expense of 45, and you accumulate it over that 1 year period from the end of year 1 to the end of year 2. And we less from this So we are lessing the amount that is payable if this life actually dies within that 1 year. So, and how do we get that amount? We simply multiply the 30,000 with the probability that a life who is now age 49 dies within the next 1 year. So remember, initially they were age 48. So if they survive to the end of the year 1, they will now be 49. But because again we are dealing with the M92 select mortality table, our select duration has not ended. Yeah. So we'll consider our age of 49 to be expressed as 48 select plus 1. And so our numerator will be composed of that, and we divide that with the probability of actually surviving from age 49 to 50. So if you evaluate this, it gives you the value of 26,807.6, which if you compare to our original computation, which is what we had earlier using this method. So you can see it compares, or it is actually almost equivalent, except for the decimal. It's 26,808, and we have now the 26,807.6, which can be rounded off to 26,808. So it means, therefore, again, we can now, instead of going through the entire process, if you have the same equation, let's say this was our original question, and it had another second part where you are asked to compute the gross premium retrospective reserve as at the end of the 3rd year, then you need not to go through this entire computation. So as long as you now have the reserve as at the end of the 2nd year, you can now apply this approach to be able to obtain the reserve as at the end of the 3rd year. So which is actually what is computed in this case. So this is the equation which we would want to evaluate for the reserve as at the end of the 2nd year, where you'd have to compute all this individually like we did in the earlier example. However, we are saying that we can simply take it to be the reserve as at the end of the 2nd year minus the expenses which have been incurred between year 2 and 3, which is what we have there as 45. You accumulate that, and you less the cost of benefits, where the cost of benefits are only payable if the life actually dies. So that will be 30,000 times the probability of actually dying between ages. Now they are at 50, between 50 and 51. And then you divide that with the probability of actually surviving between ages 50 and 51. And you can see the final answer arrived at here is the same as the same answer you'll have arrived at if you used the long method. So the two of them are the same. So kindly go through this, do the solutions on your own, and then we shall revisit this or iron out any questions stemming from the topic once you're done with your exams.